Geometry basics. So we're just going to go over a little bit of basic geometry that a 7th grade level would learn. The goals of this is to know a few things. First, the difference between area and volume, the difference between a 2-dimensional object and a 3-dimensional object, the area formulas for basic shapes, the volume formulas for basic shapes, and also that will include surface area for basic shapes. So now we need to look into a 2-dimensional object versus a 3-dimensional object. So what is a 2-dimensional object? 2-dimensional is a set of line segments or sides all lying on a single plane. An example of this would be a square or a triangle or a circle. 3-dimensional objects are a set of plane regions and surface regions all lying in a 3-dimensional space. So each face of a 3D object is actually a 2D shape. And examples of this include a cube or a sphere. One way to gauge if it's a 2-dimensional object versus a 3-dimensional object is if you can pick it up in your hands. If you can hold that object, then it's going to be 3-dimensional. Because you can never hold a square or a triangle, you would have to hold a cube or a pyramid. So now we're just going to go over a couple of shapes and decide if they're 2-dimensional or 3-dimensional. So this is a square, obviously. This would be a 2-dimensional object. Now this would be a cube. Since you can pick it up in your hands, it would be 3-dimensional. A circle, you can never find just a circle and hold it in your hands, so it would be 2-dimensional. A sphere, on the other hand, you can hold a sphere. A good example is a globe. You can hold a globe, so it would be 3-dimensional. This would also be 3-dimensional because you can, again, hold it in your hands. And a triangle, you'll never find just a plain triangle that you can hold, so it is 2-dimensional. Here are some basic definitions. Area, a measure of how much space there is on a flat surface. Surface area, on the other hand, is the total area of the outside surfaces of an object. Just a quick hint here, area will always be a 2-dimensional object. The surface area of something would be a 3-dimensional object because you're measuring all the surfaces, and a 2-dimensional object only has one surface. Volume is the measure of how much space an object takes up. So let's look at some examples of area in 2 dimensions. So let's remember, area is again a measure of how much space there is on a flat surface. So here are some formulas we need to know. For a square or rectangle, area equals base times height. For a triangle, it's going to be half the base times the height. And for a circle, it's going to be pi times the radius squared. And remember, radius is 2 times the diameter. So let's look at an example using area. Here we see that the height is 4 units and the base is 3. So let's recall that area is 1/2 the base times the height. So from here we're just going to put in what we know are givens into the formula. So we're going to get the base again is 3 units. The height is 4 units. And so here's what it looks like when you plug it into the formula. 1/2, 3 times 4, and that calculates out to be 6. So now let's find another area, this time of a circle. So again, still a 2-dimensional object. Here we're given the distance from one part of the circle to the other edge of the circle to be 10 units. Remember, that's the diameter. So that would be 2 radius equals 1 diameter. So let's recall the area formula. Area equals pi r squared. And again, we just discussed that the diameter is actually 2 radius. So the radius is 5 in this case because a radius goes from the center outward. And then plug it into the formula. We'll get area equals 5 squared times pi, and that calculates out to be 25 pi. Now we're going to move on to area in a three-dimensional object. So this again is surface area. So remember, surface area is the total area of the outside surfaces of an object. Formulas. For a cube, the surface area is 6 times x squared. A rectangular prism is 2 times AB plus 2BC plus 2AC. And a sphere is 4 pi r squared. And a rectangular prism is 2 times the area of the base plus the perimeter of the base times the height. And we'll go over what all of these variables mean, like the A and the B and the C and the X, when we get to examples. So let's look at an example using finding the surface area of the sphere. So here we're given that the radius is 10 units. So let's recall our surface area formula, which is 2 pi r squared. And then we're just going to plug in what we know. Our given is that the radius is 10 units. So now we have 4 pi, r becomes 10, and then we're going to square the 10. That would equal 10 times 10 is 100 times the 4 pi. Simplified, that equals 400 pi. Let's see here. Now we're going to look at another example using surface area. This time we're going to find the surface area of a rectangular prism. So this is a rectangular prism. Recall that the surface area formula is 2AB plus 2BC plus 2AC. Now that sounds complicated, but really when we get down to it, it's not that complicated. So in this case, one of your variables that you are given, or one of your givens, will become A. Generally, that's the base. B would be the height, and C would be the width. So let's see what that looks like. We're going to have 2 times the base, which is 6, and the height, which is 2, plus 2 times the height, which is 2, and the width, which is 3, and then plus 2 times the base again, which is 6, and the width, which is 3. And then we just have to simplify. So the surface area, 6 times 2 times 2 would be 24. 2 times 2 is 4, times 3 is 12. And then 6 times 2 is 12, times 3 is 36. So now we're down here, we just have to do some basic addition, and the surface area equals 72. If you're ever confused, just remember that each one of the numbers has to go to each other. So the 2 has to go to the 6 and the 3 has to go to the 2 and the 6, and the 6 has to go to the 2 and the 3. What this is actually doing is finding the area of this space, this rectangle times this rectangle times this rectangle, and then they're adding them all together. So it's just breaking down the individual shapes and then finding those areas and then multiplying from there. Let's look at an example using volume. Let's remember the definition of a volume, which is volume is the measure of how much space an object takes up. Some formulas. A right prism equals the area of the base times the height. A sphere equals 4/3 pi r squared, r in this case being the radius, and a cube is x cubed. A rectangular prism, just like a right prism, is the area of the base times the height. So let's look at an example. Let's find the volume of the sphere. We are given this, which would be the diameter. So the radius in this case would be 2 radius equals 1 diameter. So 10 divided by 2, the radius would be 5 in this case. Let's recall the formula for volume, which is 4/3 pi r cubed. So then we just have to find the radius, which I just did. The radius is 5. Plug in your givens. So you have volume equals 4/3 pi times 5 cubed. 5 cubed is 125. So then we have 4/3 pi times 125. Simplified, that is 600 over 3 times pi, which is 200 pi. Let's look at another example of volume. So we're going to try and find the volume of a right prism. Volume of a right prism, remember, is the area of the base times the height. Volume is 1/2 the base, in this case is the triangle, so you're going to do 1/2 the base times the height of the triangle, and then times that by the height of the shape. So let's do this again. So this is a triangle, this is the base of the right prism, so that's where we get the formula 1/2 equal 1/2 base times height, because that's the area of a triangle, and then the height of the object is 6 units. So there are 2 h's in this equation, but don't get confused because they belong to different numbers. So let's find the volume of the area of the base, which is 1/2 times 2 times 4, just a general area for a triangle, and then the height in this case is 6. So simplified, that's going to be 4 times 6, which is 24 units. Let's review what we've learned. Volume is the space taken up by an object. The surface area is the total area of a three-dimensional object. So remember, surface area is only in 3D, and area is in a two-dimensional object. And area is measured on a flat surface. This is my works cited.